There's a second one?
Yeah.
Really?
Yeah.
All right. So
David, pause it.
we know that the amount of work, the energy put into this, is going to be the change in kinetic energy. And we know kinetic energy is given as m c squared. You better hurry. I gotta look this one up too. M naught c squared. So her resting mass times c squared times 1 over our radical. But we actually need the change in this. So we need this to be our kinetic energy 2, KE2, minus our KE1. So let's make sure we know what KE1 would be as well. So that'd be minus the next term, m naught c squared, 1 over 1 minus, and now at rest it'd be 0 over c minus 1. Well, what's 0 divided by c?
0.
Okay,
Zero.
so that'd be 1 minus 0, so that's 1. Square root, 1 over 1.
Minus 1.
That'll leave me
So
0.
that whole term is gone.
Okay, sweet.
Alright, that makes me feel better.
So we really only care about this, but even for me, I like to go back through this and let's just double check, shall we, about how, just to make sure that I've got that right and I'm not oversimplifying. But now we can put our values in for the amount of energy she'd have. So her mass was 98 kilograms. We have to use the speed of light here. It's not the most annoying thing ever.
What, that? Or your most annoying noise ever?
That noise is.
We are whiners, geez.
Yes. You just listed like 100 rules.
It's a double decker.
And no consistency.
It's not to work.
I need to study my watch a Lego.
Oh, you just square the speed of light.
I could bring the Lego movie in after the seniors are all gone, and we can watch it then.
Oh, dude,
That's
good
cool.
for-
Yeah, that helps me.
That's probably where we went wrong.
I'll watch it.
Wait, what'd you ask me at?
Aren't they making another Lego movie?
Yeah.
Probably it did really well.
It was really cool. It's the orb of teeth.
Yeah, what am I doing wrong here?
Oh, yes. This is
I super hate you.
Alright, that makes sense.
That's what I got.
9,231. I got 7.923 times 10 to the 18.
Wait.
1.7 times 10 to the 19.
I beg your pardon. I had another number from a different problem in there that I didn't realize when I started typing. So this is wrong.
Ding dong.
It is 7.92 or 7.9 times 10 to the 18. So correction there. Add something. Does that agree with everyone now?
Yes.
Well, no, but yeah. Did you subtract them?
Okay, a velocity addition question. The first thing to look at is, or consider is, approximately how fast do you think this is going? So she's going towards Earth at 0.85 c, but throws the ball backwards, so it's probably going slower than 0.85 c, according to an Earth observer. If she threw it towards Earth, of course, it would be going faster than 0.85 c, but not above c. So you always have some sort of a ballpark to put this in. When we are looking at the velocity between Earth and the ball, we would take her velocity, so our starting Earth and, oh, that's not good. Let's make the ball a lowercase b. We take the velocity between Earth and Bobby. We'd have to subtract the velocity between Bobby and the ball because that's in the opposite direction. And then we could take the values down here. VEB negative VBB. over c squared, and then put our values.
I screwed up that part.
And as usual, I'm going to keep my speeds in terms of c to make that easier. So this will be a negative now. I'll give it a go as well. That seems perfectly reasonable.
What? I must make it later. Oh yeah.
That's what I get too. And a perfectly reasonable number.
Would it be alright to leave it in terms of C?
Yeah. No, normally that's what I do. I mean, that's why we use c to make it a convenient number.